Welcome, guys, back to my channel. My name is Trisha Morris, and today we'll be doing integration of even and odd powers. Let's get started.
So we'll be doing the integral of sine nx, where n can be odd or even, the integral of cos mx, where it can be odd or even, and the last one is where we have a mixture of power, and today I'll be doing just when we have an even power, both being even. But later on, in my next video, you can see the other mixture.
Now, integration of even powers. Here we have an example. Evaluate integral of sine square 2x dx. So remember I said once you have an even power, we will be using the first formula, which is sine square a equal a half 1 minus cos 2a. So if this was 2a, then it means I'll have a 4a here. If this was 6a, then I'll have 12a. So this is just saying that we double a. So looking at this, I have 2x. So applying the rule, it becomes a half 1 minus cos. Doubling the 2x, so it becomes 4x. So all of this, we substitute it for sine squared 2x. So we have a half 1 minus cos 4x. The dx is just showing that we're integrating with respect to x. So here we're going to carry out the half. Now we have 1 minus cos 4x. The integral of 1 is x. The integral of cos 4x is a quarter sine 4x plus my constant c. Now we have the integral of cos 4x dx. This is an even power, so first we write cos 4x as cos square x all squared. So cos square x all squared. Now cos square x, just to remind you, using the identity, cos square a is equal to a half 1 plus, not minus, but plus cos 2a. Now if you realize I have a quarter here, it's a quarter because of the square.
So explaining this further, we have cos square x, and we know from the identity that cos square x, it's the same thing as a half, open bracket, 1 plus cos 2x. But because it's squared, it means you're multiplying it twice. So we're squaring all of this. So the half, if I square the half, I will have a quarter. So squaring half, we have a quarter. Then we have 1 plus cos 2x all squared. Now we're going to expand this. It means we're doubling it. So expanding it, what we'll have is a quarter, open bracket, 1 plus, so 1 plus cos 2x multiplied by 1 plus cos 2x. So the cos 2x all squared is just multiplying it twice. So now we're going to expand. So writing a quarter time, and then we multiply 1 times 1, that gives us 1. 1 times cos 2x, that gives us cos 2x. Then cos 2x times 1, that gives us cos 2x. Finally, cos 2x times cos 2x. That will give us a cos square 2x. So writing it, I have the cos, square on the s, and then 2x. Now we can simplify this further because the center, we have cos 2x plus cos 2x, they can be added. So adding the cos 2x plus the cos 2x, it will give us 2 cos 2x. So this means that the expansion of cos square x all square is a quarter 1 plus 2 cos 2x plus cos square 2x.
So that's what we have here. We expand 1 plus cos 2x all square to arrive at 1 plus 2 cos 2x plus cos square 2x dx. Now, cos square 2x, we can apply the rule once more. Remember, cos square a is equal to a half, open bracket, 1 plus cos 2a, close bracket. So if I have 2a, then this will double to give us 4a. So here we have 2x, so we double it to get 4x. So it's a half, open bracket, 1 plus cos 4x. So replacing the cos square 2x with what I have here, we arrive at quarter integral 1 plus 2 cos 2x plus a half. So this part, replace the cos square 2x to give us a half, open bracket, 1 plus cos 4x. Now, I need to show you what's happening here. We integrate the 1, so we carry out the quarter, integrate 1, we get x. Integral of cos 2 cos 2x, 2 cos 2x, have 2 sine 2x over 2. This cancels, so we're left with sine 2x. Integral of a half, open bracket, 1 plus cos 4x. You integrate 1 to get x, then integrate cos 4x. You get sine 4x over 4. However, we have a half outside, so multiply the entire bracket by a half. So this becomes x over 2. Half times x is x over 2. A half times sine 4x, 1 times sine 4x gives us sine 4x. 2 times 4, that gives me 8. So the x over 2 plus sine 4x over 8. And that's what you're seeing here. X over 2 plus 1 over 8 is the same thing as sine 4x over 8. Now, distributing and simplifying, that's what's happening here. X plus x over 2 is 3 over 2 x plus x over 2, put this over 1, find LCM, 1 into 2 goes 2 times, 2 times x, 2x, 2x, 2 into 2 goes 1 time, 1 times x, x 2x plus x gives us 3x over 2. Then we have a quarter outside, so multiply it by a quarter. So 3x times 1, that gives us 3x. And 2 times 4. And 2 times 4 gives me 8. So it's 3x over 8, which is what we have here. Then we have a quarter times sine 2x give you a quarter sine 2x. And then 1 over 8, 1 over 8 times a quarter gives you 1 over 32 sine 4x plus c. We can also have the integration of odd powers where we decompose the function based on the power odd, even, plus 1. So a little background information, if we have the integral of sine nx cos x dx, it is sine n plus 1x over n plus 1 plus c. If you have the integral of cos nx sine x dx, then it's minus cos n cos to the n plus 1 x over n plus 1 plus c. So let us look at the integral of cos cube x dx. Have here is that cos cube, we are going to rewrite it in terms of even and odd, even plus 1. So we have the cube is the same thing as cos cube is the same thing as cos square x times cos x. Then we rewrite cos square x as 1 minus sine square x. Just to remind you, sine square x plus cos square x equal 1. So cos square x is equal to 1 minus sine square x. You can also have sine square x equal 1 minus cos square x. So we'll be using these identities. So here we change cos square x as 1 minus sine square x with the above. So we have the integral of 1 minus sine square x cos x, then distributing the cos x within the bracket. So cos x times 1 cos x times sine square x gives you sine square x cos x. The integral of cos x, it is sine x, and then this follows the rule sine n to the power x cos x dx. We add 1 to the power and same in the denominator. So adding 1 to this power, you will have 3. And then some persons like to have sine cube x over 3 or a third sine cube x plus c. Sine cube x, replace it as sine square x times sine x. Then sine square x using the identity is 1 minus cos square x. So this 1 minus cos square x, now we're going to multiply that bracket by sine x. So multiplying it by sine x, just a reminder, sine x times 1 gives us sine x. Sine x times cos square x gives us sine x cos square x. Now, the integration, as you can see, we have sine x gives you cos x, while the cos square x sine x, using the identity, integral of cos raised to the power n x sine x dx is minus cos n plus 1 x over n plus 1 plus c. So that is why the cos square x sine x, leave the minus sign as is, and 2, we add the 1, it becomes minus cos cube x, and whatever is the power goes in the denominator, so it'll be over 3 plus the constant c. Now the two negatives become positive, so the answer is cos x plus cos cube x over 3 plus c. We can also have a mixed power. Here we have it being 2 even. We could have an even or an odd. So here we have the integral of 8 sine squared 3x cos squared 3x. Factor the 8, leaving the sine squared x, change cos squared 3x as 1 minus sine squared 3x. Now multiplying sine squared 3x times 1 gives you sine squared 3x. Sine squared 3x times sine squared 3x gives you sine to the 4 3x. No, we know that sine squared 3x coming from this is a half 1 minus cos 2a. So we're using this formula. So sine squared 3x, this would be 3x, it becomes 6x here. This is what we have here. So it's a half 1 minus cos 6x. The sine 4 to the 3x, sine 4 3x is the same thing as sine squared 3x times sine squared 3x. Then applying the same rule, we'll have the same concept where sine squared 3x will be a half 1 minus cos 6, and the same thing here. But a half, because we're multiplying, we multiply the half twice, so we'll get a quarter. Then we'll have the two brackets to represent the sine squared 3x as what we did right here. No. So this is the line that we have. So rewrite the half, 1 minus cos 6x. We have the quarter. Now multiply. So we have 1 minus cos 6x times 1 minus cos 6x. So multiplying this, 1 times 1 gives you 1. 1 times minus cos 6x gives you cos 6x. Negative cos 6x times 1 gives you negative cos 6x. And negative times negative gives you positive. Cos 6x times cos 6x gives you cos squared 6x. Now, adding these two, we'll have 1 minus 2 cos 6x plus cos squared 6x. So that's what we have right here. Expanding this, we have 1 minus 2 cos 6x plus cos squared 6x. Now, cos squared 6x can go further. Yes, it can. Cos squared a is the same thing as a half 1 plus cos 2a. So if I have cos squared 6a, then it becomes a half, open bracket, 1 plus cos 12a. So that's why the cos squared 6x become a half 1 plus cos 12x, because we doubled the 6x. No. So I'll be doing this simplification first. So this is a line that we have a half, open bracket, 1 minus cos 6x minus a quarter, open bracket, minus 1 minus 2 cos 6x plus a half, open bracket, 1 plus cos 12x, close bracket. So multiplying the halves, a half times 1, that's a half. Half times minus cos 6x is minus cos 6x over 2. Then minus a quarter times 1, that's minus a quarter. Minus a quarter times negative 2. That will give us positive. Now, I'm just going to write 2 over 4 and simplify it further. Then we have cos 6x x. Now when we multiply negative a quarter times positive a half, that will give you negative 1 over 8. So this negative 1 over 8, multiply the bracket, minus 1 over 8, and negative 1 over 8 times cos 12x will give you minus cos 12x over 8. Now we're going to integrate this. This is what you're going to see on the slide. Integral of a half is x over 2. The integral of cos 6x over 2. Remember, integral of cos is sine. Rewrite the 6x. Then this 6 times 2 gives us 12 minus integral of minus a quarter would be x. 4, and some persons like to write this as a half x and a quarter x. That's fine. This can cancel, so we have 1 over 2. So this is the same thing as cos 6x over 2, and when we integrate this now, we'll get sine six x over 6 times 2 to give me 12. And again, this would be 1 over 8x or x over 8. And then integrating this, we'll have sine 12x over 96. So if you're wondering how we get the 96, we by 12 times 8, and that's how we get the 96. So this line, I didn't show this step, so that's what you saw on the whiteboard. Now multiplying the 8 by what we have in the bracket, 2 into 8 goes 4 times. So that's why we have a 4x. We have 8 over 12. So when you reduce this, 8 over 12 becomes 2 over 3. 4 into 8 goes 2 times. Multiply this, 2 8 16. When you reduce 16 over 24, we have 2 over 3. The 8's cancel, that's why you're seeing a minus x. And 8 into 96 goes 12 times. 4x minus 2x, that's 2x. And 2x minus x, that gives us x. This part, no, they're the same, so it cancels.
So we're left with sine 12x over 12 plus c.